Hello everyone. In this video we will see how to program your Raspberry Pi Pico using MicroPython and CodeSkool. So to get started, first you need to install the Python on your machine. So Python is not required to run any MicroPython code. It is just for one tool which we will be using to upload our code on the target device. So once you have the Python on your system, you have to install that Adafruit MicroPython tool. So this is the tool actually upload our code to the target device, which is Raspberry Pi Pico. So to install this tool, you have to run this command on your command prompt after you install the Python. So this will install the Adafruit MicroPython tool, which will actually upload our code to the Raspberry Pi Pico. So the next thing is you have to download this UF2 file. So this file is basically your MicroPython framework for Raspberry Pi Pico. So once you have downloaded this file on your machine, you have to press and hold the boot cell button, and then you have to plug your Pico into the USB port of your machine. So while doing the power, you have to press and hold this boot cell button. So once you do that, that RPI RP2 drive will appear in your machine, and in that drive you have to copy the downloaded MicroPython framework file. So after you have copied that MicroPython framework to the RPI RP2 volume, you have to again reset your device. So Raspberry Pi Pico do not have a reset button. So the way it works is like you remove your USB cable and plug it again. So disconnect power and again connect the power to reset it. So once you have done this step, your device is ready to program using MicroPython. So we will be using this Raspberry Pi PicoZero library, which is a MicroPython library written for Raspberry Pi Pico, which will make it much easier to assess the device peripherals or connected LEDs, buttons, speakers, etc. with the Raspberry Pi Pico. So this library actually makes it much easier to program on Raspberry Pi Pico. So you can go on this URL and you'll find some recipes like code snippet which you can use and run it on your Raspberry Pi Pico. So now we are ready to program the Raspberry Pi Pico in MicroPython using CodeSkool. So before started programming, you have to install a code connector application, like code uploader kind of application, that will take the code from your browser and actually upload it to the target device Raspberry Pi Pico. So to install the code uploader, you have to go into the settings and then you have to download this zip file, and once you unzip it, there would be an installer.exe. So once you run this installer.exe on a command prompt, it will install a lot of other files. For example, this CodeSkool.exe. So once the installer has installed all the files, you are ready to go. So we will just run the CodeSkool. Now our CodeSkool application is running. So we need to again refresh our browser. So once you have refreshed your browser, we are ready to program in MicroPython. So the first thing you need to do is go into extension and enable this MicroPython extension. If you want, you can find some example code also. LED pulse or push button, RGB demo, speaker, etc. So these are pre-written example based on this snippet code. which you can use it. The next thing is like you have to go into the editor mode from the stage mode, because we are actually programming the device. And as you see, like I had already connected my Raspberry Pi Pico and it is connected to COM3, so I have to select the correct COM port. Now let's write a very simple program. So on Pico run, I will just turn the default LED on. So Pico LED is the default LED which is connected to the GPIO 25. So this simple program will just turn the default LED on. So now I can do upload, and as you can see, like it has uploaded the code and the code has been already run on the machine, and you can see that LED is now on. Similarly, I can turn off that LED also. So this LED I can turn off. I just need to upload it again. So now it will you call the off function and turn off the LED. So the code is uploaded and the LED is turned off. Let's just see the example code. So this is the LED pulse code which will create a glowing effect. So as you can see, I had connected a LED on the GPIO 14, and then I'm like setting the brightness of that LED using this mathematical functions. We will not go into much detail about this mathematical function because this video is not about mathematical functions or like programming or in general. This video is about like how to use CodeSkool to program the Raspberry Pi Pico device. So as you can see, like this code will like change the brightness of that LED using a sine wave kind of thing, which will create a glowing effect. And as you can see, like I have defined some variables here. So let's just run this code. Again, I have to select the correct COM port and I'll just say upload. And the code is already uploaded. And as you can see, it is running also on the target device. And not sure like if you can see on camera, but there is a glowing effect. It is hard to see on camera, but if you look it from the sideways, you will see a glowing effect, kind of like a candle or something. Let's just see another example. So this example, we will check the state of a button, and if the button is pressed, we will just toggle the LED. Again, I have to select the correct COM port and just click the upload. And the code is uploaded. So let's just see the demo. So I'll just press this button and you can see the LED is turned on. And the push button will toggle the LED. So instead of using this button press state check and like waiting for 1 second to like before checking the state, you can use this function also, like when button press, call your predefined function. Let's just see another demo. So this is the RGB pulse demo. So it will change the RGB color which is connected on pin 2, 1 and 0. So as you can see, this is the RGB LED It's a common cathode which I have connected to this pin 2, 1 and 0. The red, green, blue. So let's just run this code and see the demo. I can reset my board and I'll try to upload it again. Now the code is uploaded and you can see the LED blinking and changing through various colors. Again, it is hard to see on the camera, and this LED will like not show the true colors. It's just simple RGB LED just for the demo purpose. So for example, it will not show the true white kind of color, but you will get the idea, like it is pulsing through various colors: red, green, blue. Let's just run it again. I'll reset the board. So you can see like this is purplish color. Then it is cycling through red, green, blue, and it is slowly shifting through these various colors: red, green, blue. Let's just see another example. So this is the speaker example. So I have connected a speaker here, and like this is the music tone data. So I just copied it like that only. Basically in this try finally event, it will like take each note and it will play it individually. So let me just upload it. So like as you were able to listen, like, so this is like a very small speaker, so I'm not sure like how the sound quality will come on the microphone, but it has played some musical tone using that speaker. So as you can see how easy it is to program the Raspberry Pi Pico to do various things using CodeSkool Scratch environment. So I have few more examples if you want to see, like this is a very simple example which will like print the internal temperature. I just change it to 1 second. So let me run this code. And the code has uploaded and it has started running. So to see the serial output, you have to go into the serial tab, select the correct COM port, and then click on the connect button. Because the COM port is already open by the run command, so what we do is like we just reset our board. So that run command is finished and the default main.py will automatically start execution, and now we can connect it again and you can see like internal temperature. every 1 second it is checking the internal temperature and printing the data here. So I can close the connection, clear the logs. So before uploading your code, make sure like you have disconnected the serial communication so that the uploader, which is like the Adafruit MicroPython tool, can assess the COM port. So like if your COM port should not be in use, so just disconnect it from here before uploading any code. So one more thing, like I've connected a reset button here, which is connected to the run pin of the Raspberry Pi Pico, and the other end is connected to the ground. So when I press this button, this Raspberry Pi Pico will get automatic reset. So it is actually much easier for me to demo by just resetting it instead of like removing the USB cable and powering it again. So it's not required, but it provide an additional convenience. Instead of like removing your USB cable and plugging it again into your USB port, you just have to like press this button, which would reset this Raspberry Pi Pico. Let's just see one more example. So this is the potentiometer example. So like there are a lot of issues in the Raspberry Pi Pico documentation. For example, like somewhere it just says like from Pico import port, but there is no Pico. It should be like from PicoZero import port. Similarly, like there is no percent defined on this port. So anyway, like we have taken care of all those things, and like so like when you use CodeSkool, it will generate the proper code which will run on your Raspberry Pi Pico. So let me just upload it, and it has uploaded it. And because it is also running it, and this run command and this run tool basically is using that COM port, so we have to first reset our device to like stop that tool from assessing that COM port. Now we can go into serial, select the correct COM port, select the correct port rate, and then click on connect. And you can see this data like potentiometer data which is coming through. So because it's coming too fast, like I'll just change it to 1 second. Now let me upload it again. So it has already uploaded and running it, so I have to reset it again. Now again I can connect to that serial port, and you see like if I change this potentiometer now, this data will actually change from 0.0 to like it will go till 1 and 3.3 volt. So I can again decrease it, like this is 0.8, 0.7, 0.6, 0.54, like that. So let's just see a buzzer example also quickly. So let me run this example. So as you have heard the buzzer beeping, so we can use this buzzer functions to control the buzzer. So these are the speaker function, buzzer function, potentiometer, RGB LED, button and like LED. So you can create various functions also in MicroPython. So just like regular Scratch function, you can create your own function and you can organize your code in a more structured way. And it will automatically generate a proper formatted and organized code for you. You can also add like comments and all those things which it would output into the code. So as you can see like how nicely the code is generated, like it is a complete readable code. Like it's not like machine generated code which only machine can understand. It is a machine generated code which anybody can understand. So let me just upload this code. And this is the code for RGB LED. So I hope you like this video and how easy it is to program your Raspberry Pi Pico using the MicroPython framework, PicoZero library and CodeSkool. So thanks for watching and have a nice day.